Alright, this video is on section 11.5, recursive rules for sequences. We're going to start with a review problem from 11.4, finding the sum of an infinite geometric series. So if you remember the equation for finding the sum of an infinite geometric series, it's the sum equals the first term divided by 1 minus the common rate. Now remember, the common rate has to be less than 1 in order to use this equation. So if the sum only exists if your rate that you're multiplying by is less than 1. We can use the summation notation to help us find our first term in our r, because this is our rule, and it's a sub 1 times r to the n minus 1. So that means our first term has to be 3, and your rate has to be 0.8. So that means our sum, plugging into this equation, is going to be 3 divided by 1 minus 0.8. So 3 divided by 0.2. And 3 divided by 0.2 is 15. So the sum of that infinite geometric series is 15. All right, part 2 on review problems. An infinite geometric series with a first term of -6 and a sum of -8. What is the r? We're using the same formula, so s equals a sub 1 over 1 minus r, except for this time it gives us our sum. This is our s and our a sub 1, and we want to solve for r. So -8 equals -6 over 1 minus r. In order to solve for r, you're going to have to get this 1 minus r out of the denominator by multiplying both sides by 1 minus r. Over here, that'll cancel, you get -6. Over here, you have to distribute the -8. You're going to get -8 times 1 is -8. Negative r times -8 is positive 8r. Trying to move the screen down a little bit here. There's my little thing. Okay, solving for r, I'm going to start by adding 8 on both sides. 8r equals -6 plus 8 is 2. Divide by 8 on both sides, and 2 over 8 reduces to 1/4. So r is 1/4, which is less than 1, and that makes sense because I told you the sum was -8. For the sum to exist, the r has to be less than 1. All right, this is on recursive rules for sequences. We've learned explicit rules before. Explicit rule gives an a sub n as a function of the terms in position n in the sequence. Example of an explicit rule is like a sub n equals 3n plus 6. So just a rule where you can find any term in the sequence given that rule. So if you wanted to find the 6th term, you do a sub 6 and you plug in 6 for n. Recursive rule is what you're learning today. It gives the beginning terms and the equation that tells you how to find the next terms relating to the previous term. So reminder that a sub n minus 1 is the previous term. So the recursive form of a geometric series, so this is for geometric. I know that because it's giving me r, is you give me the first term, a sub 1 equals some number, and then you find a sub n. The rule is the previous term times r, where r is the common rate, a sub 1 is your first term, a sub n minus 1 is your previous term. Here's an example. 2, 8, 32, 128. So how is this series changing? We're multiplying by 4 every time. So r is 4. So if I wanted to write a recursive rule for this, you have to first give me the first term. So the first term is 2. Then I get any term in the sequence by taking the previous term, a sub n minus 1, times 4. 9, 3, 1, 1/3, how is it changing every time? What are you multiplying to get from 9 to 3, from 3 to 1? If it's not completely obvious, you could always take the second term and divide it by the first term. So 3 divided by 9 is 1/3. So 9 times 1/3 is 3. 3 times 1/3 is 1. 1 times 1/3 is 1/3. So that means R is 1/3. So my recursive rule is, okay, my first term is 9. Then my a sub n is the previous term times 1/3. So let's practice using the recursive rules to find the terms in the sequence. So this tells me that the first term is -2. Then the rule is you take the previous term times -3. So to find the second term, I take the previous term, -2 times -3. That's 6. Find the third term, you take the previous term, 6 times -3. I get -18. To find the next one, you got to do -18 this time, times -3, equals 54. Then to find the next one, you take the previous term, which is 54, times -3, which is -162. Over here, it's telling me the first term is 4, and it's 2 times the previous term. So if the first term is 4, and it's 2 times the previous term, the second term is going to be 2 times 4, which is 8. Next one's going to be 2 times 8, which is 16. That's 2 times the previous term, so 2 times 16, which is 32. 2 times the previous term, 2 times 32, which is 64. Go to the next page. All right. All right, let's practice writing rules for the geometric sequence. I'm telling you that the first term is 4 and that the common ratio R is 0.2. So an explicit rule for geometric sequences is a sub n equals a sub 1 times r to the n minus 1. So to write that rule, it's just a sub n, where a sub 1 is 4, r is 0.2 to the n minus 1. This rule for a sub 1, I can have any term in the sequence. If I asked you to find the 100th term, you could plug in 100 and figure it out. For the recursive rule, you have to use this formula up here. So first you have to state what the first term is. So a sub 1 is 4. Then the rule is the previous term, so a sub n minus 1, times r, which is 0.2. So that's the recursive rule. Now the recursive rule is nice because you just multiply by r every time, but you have to go in order. So if I asked you the same question to find the 100th term, you would first have to find the first term, then the second term, then the third term, all the way up in order to get to the 100th term. So the recursive rule doesn't really work if you want to find any term. That would be more of an explicit rule. But you just take the previous term times your rate gives you the next term in the sequence. So the recursive rule is to go in order of terms. Here's another example for the recursive geometric sequence. So I wrote the explicit rule and I wrote the recursive rule, and I have the answers there. So if you want to try these on your own, go ahead and pause the video. Try them, check them out, make sure you get the same thing. Next, we're going to talk about arithmetic sequences and rules for that. So recursive form for arithmetic, that's when you're adding or subtracting the same number every time. That's where you use the common difference. A sub 1 is still the first term. A sub n minus 1 is still the previous term. So the recursive form is you give me the first term and then you just take the previous term and you add your common difference. For example, 7 to 11, you're adding 4. 11 to 15 plus 4, so your common difference is positive 4. So my recursive rule is my first term is 7. You just take the previous term and add 4. Here, looks like we're subtracting 2 every time. 7 halves minus 2 is 3 halves. 3 halves minus 2 is negative 1 half. So if I want to write, that's my common difference is negative 2. So you got to give me the first term first, is 7 halves. Then your rule is just take the previous term and subtract 2. So I want to write the first 5 terms of a sequence. In order to do this, you have to be given the first term. First term is negative 2. Then it says take the previous term and subtract 10. So negative 2 minus 10 is negative 12 is the second term. To find the third term, you use that negative 12, you subtract 10. Negative 12 minus 10 is negative 22. Fourth term, you use the previous term, so negative 22 minus 10, negative 32. Use the previous term again, negative 32 minus 10. The fifth term is going to be negative 42. Over here, you got fourth term, or first term is 4, and then it looks like it's the previous term plus 5. So to find the second term, you take the 4 plus 5, which is 9. Find the third term, you take the previous term plus 5, so 9 plus 5 is 14. Previous term plus 5, 19. 19 plus 5, 24. So in order to get the first 5 terms, you have to go in order, first term to fifth term. To use the recursive rule, you must have the previous term. So let's practice writing a rule for arithmetic sequence. Okay, remember the general rule for an explicit arithmetic sequence is a sub n equals dn plus a sub 0. So I gave you the first term was negative 7, and the common difference is 3, but to write an explicit rule, you do have to know your a sub 0 term. So if you're adding 3 every time, you have to go backwards, and negative 7 minus 3 is going to be your a sub 0, or your term before your first term is going to be negative 10, which you need for the explicit rule. So then your explicit rule, a sub n equals, d is 3, so 3n minus 10. Again, this works for any term. So if I wanted to find the 10th term in this sequence, I could just find it. 3 times 10 minus 10, it'd be 30 minus 10 would be 20. The 10th term in that sequence is 20. Recursive, you use this new formula here. You have to give me first, the first term is negative 7. Then it's just, the rule is the previous term plus your d. So just take the previous term plus 3. In order to find the 10th term now, you'd have to first find the second term by adding negative 7 plus 3. Then use that term to find the third term, then find the fourth term, and so forth. So this one you have to go in order. I have another example here of writing a rule for an arithmetic sequence when the first term's 22 and the common difference is negative 3. You can pause the video here and try to do this one on your own. When you're done, check back to make sure you got the same answers. These are the last examples we're going to go through. So first I need to decide, is it arithmetic, geometric, or is it some other kind of sequence? So 66 to 33, it looks like I'm dividing by 2. Does that work here? Divide by 2? Yep. So this one's geometric, where your common rate dividing by 2 is the same thing as multiplying by 1/2. So to write a recursive rule for this sequence, it's going to be, you got to give me the first term, which is 66, and then a sub n is going to be that previous term times 1/2. This sequence is not as obvious because from 1 to 4, you're adding 3, but from 4 to 10, you're adding 6, and from 10 to 22, you're adding 12. So you're not adding the same amount every time, so it's not arithmetic. It doesn't appear to be geometric right away because we're not multiplying by the same thing every time. 1 times 4 is 4, but 4 times 4 is 16. But down here, you are multiplying by 2 every time. So there's a little bit of a geometric pattern. What it ends up being is if the first term is 1, my rule is it looks like I'm taking the previous term and multiplying it by 2, so 2 times the previous term, and then I have to add 2 more to get to it. So let's make sure that works. I'm saying that's my rule, and I'm going to check it. So if a sub 1 is 1, then a sub 2 is the previous term times 2, so 2 times 1 plus 2. 2 times 1 is 2 plus 2 is 4. That works. Third term would be 2 times the previous term, so 2 times 4 plus 2. So 8 plus 2 is 10. It works. And the fourth term should be 22. 2 times the previous term plus 2. 20 plus 2 is 22. That is our rule. All right. Thanks for watching. See you tomorrow.